y'all doing? My name is Dr. John Belkwitz, Director of R&D at Intelligent Concrete, and we've got some Q&A this morning. So, the first question that we've got is a great question. It's a chemistry-related question that I really like. It's something that we spent a lot of time on, and it's from Film Factory. Again, Film Factory. Thanks for those questions. Just absolutely awesome questions. And the question that we got today, John, can you go into the differences between geopolymer cement and Portland cement? Can the same high-range water reducer be used? So that's two questions. And we even have an article on it that Mallory wrote. The one I want you to get into is Geopolymers Part 2, The Balance for Strength. It sounds like a Star Wars episode. But it's by Mallory. It's about a 3-minute read, and it's absolutely amazing. So yeah, let's go into it. So Portland cement relies on the balance between, and I'm using balance because of that article title, between calcium and silicon. For the calcium silicate hydrate gel that we get in standard concrete, for it to polymerize and go from a liquid to a solid, it needs to have a calcium silica ratio between 0.7 and 3.2, depending on whose paper you read. Now, where we get that from is the parent materials from the A-light or B-light, or the tricalcium silicate and the dicalcium silicate that you get in the cement composition. When those dicalcium and tricalcium silicates, or vice versa, drop into water, they start dissolving to reach some type of a balance. You know, the first thing that precipitates out of this combination of cement and water is calcium hydroxide, leaving a supersaturated solution or soup, calcium and silica, and from there we get a polymerization or gelling of the calcium silicate hydrate. Now, I've really gone into a very short window of what actually occurs, and you know what? There's a YouTube video called Cement Hydration Theater by Tyler Lay, Professor Tyler Lay and his group, that we should also put on here, which is a great video that goes into a lot more depth, and the kids actually act out the chemistry. It's amazing. So yeah, that'll get into cement pour chemistry, or the hydration process that you asked about in a certain way in your question, but your ultimate question was, what's a geopolymer? And a geopolymer, unlike the Portland cement, is a combination of binders that has no Portland cement in it. It's normally byproducts of, you know, some other production, whether it's coal combustion, whether it's steel manufacturing, ferrosilicon alloy, or maybe it's a naturally mined material. But it's something that's either reclaimed or something that's naturally mined. It's not put through a process like Portland cement is, that, you know, takes heat and the combination of materials to melt it into a clinker, and then we go from that clinker to a powder. So we're not using that type of material with geopolymer. And with the geopolymer, we're not relying on the calcium and silica balance. We're relying on alumina and silica balance, and that's what we're getting from a lot of these materials: alumina and silica. And then we have to add an alkali activator, and that's probably the most important part. The alkali activator is primarily because the alumina doesn't like to dissolve. You have to have a very high pH for alumina to dissolve and for it to combine to create that hardened structure. And Mallory has this sentence in here. So the geopolymer mechanisms include the dissolution of alumina and silica in the alkali medium, orientation of the dissolved species, and polycondensation, which forms a 3D network of alumina or silico-aluminate structures. It's a wonderful sentence that she's got here in the paper, and it's referencing another paper from back in 2007. But I mean, that's really what we're dealing with. We take, let's say, slag and metakaolin and Class F fly ash or silica fume with our rock and sand and our water glass or alkali activator, and that alkali activator with water, normally it's a lot of alkali activator and high heat, starts breaking down that alumina. It combines with the silica to create that polycondensation. And the last piece of that question, so hopefully you got through the first two, the last piece of that is, can you use the same high range water reducers? Yeah, no, yes, kinda. We've been able to get away with that in the past. We did a geopolymer concrete study for experiment.com, that Bill and Melinda Gates Foundation, where we did use, I believe it was Optima 256 EMX by Crezo, and that's online free, that information. And I believe it's actually part of one of these articles that Mallory wrote. And we've done it for an Army Corps project in the past. That being said, we didn't use the traditional alkali activators and the traditional methods to kick off that that polycondensation process. So we did it a very unusual way, specifically using nanoparticles as opposed to in combination with the more traditional geopolymer material. So it was a little bit different, and I think folks have done that in the past, but normally you wouldn't use the traditional high-range water reducers that you use for Portland cement-based binders, because those traditional high-range water reducers are tuned in to those Portland cement chemistry and physical composition. So yeah, I know that wasn't a straight answer for that last piece, and I apologize a little bit, but I mean, it really depends on what you're trying to make. So there's a lot of great information out there. Universities, Texas, Austin, Professor Maria Younger does a lot of great research on geopolymers, so that's a great place to start. Just be wary that with those alkali activators, they are not easy to use. They can be fairly caustic, so yeah, just be safe. Let us know if you have any questions, and good luck with your experiments if you are going to do any. Thanks for your time. Hope you learned something today. Don't forget to like and subscribe. Blah, blah, blah. Go concrete. Beat asphalt.